The Earth's ozone layer plays a pivotal role in the health of every biological organism on the planet. The ozone layer is located in the Earth's atmosphere, primarily in the stratosphere with smaller amounts in the troposphere and mesosphere. Ozone acts as a metaphorical sunscreen, deflecting harmful ultraviolet radiation away from the Earth's surface. This ultraviolet radiation is essentially energetic solar photons with the strength to break the bonds of biologically active molecules, such as DNA. Without the ozone layer, more and more of this harmful radiation would reach the Earth's surface and thus cause problems for humans, flora, and fauna. In 1985, it was discovered by Joe Farman, Brian Gardner, and John Shanklin that the levels of ozone over the Antarctic were depleting rapidly. It was later determined that the cause of this depletion in the ozone layer was CFCs produced by humans. CFCs were used for a variety of different things, from air conditioners to refrigerators. Shortly after this discovery, it was decided that these CFCs should be regulated to protect our planet's ozone layer, and such, the Montreal Protocol was born.
The Montreal Protocol was signed in September of 1987. It was designed to reduce the production and consumption of ozone-depleting substances and CFCs from sources as refrigerators, aerosols, and air conditioners in order to protect the ozone layer. Since it was established, it had been strengthened through 5 amendments, adding new ODS and rescheduling some phase-out dates. By 2009, all the countries have ratified the treaty, making the protocol the first international environmental treaty to achieve complete ratification. That shows that all countries are aware of the complications of ozone depletion and are committed to reduce ODS. Considered the most successful environmental protection agreement, the protocol set a mandatory timetable for phasing out ODS for developed and developing countries. Since the signing of the protocol, concentrations of ODS and CFC have been decreasing constantly. Improvements are visible and concrete. As we can see by the time-lapse, if it wasn't the protocol, the ozone concentration in the future would be dramatically lower than with it. In fact, that had already been confirmed by an IPCC review in 2005, which concluded that the amount of ozone has now almost stabilized. The recipe for the success of the protocol is easy. First of all countries had the common vision of protecting the ozone layer. Secondly, the phase-out quantities and dates were feasible goals to reach. And thirdly, there were a multilateral fund that supported the developing countries to achieve their phase-out needs. It is important to highlight that although there was a penalty to countries who didn't obey the protocol, what motivated them to follow it was the viability and great outcomes that it showed, both in environmental and economical fields.
After the creation of the Montreal Protocol, if we look at the economy of some countries, it is important to create a correlation between the increasing GDP and the reduction of emissions that are related to the destruction of the ozone layer. One good example of how the Montreal Protocol could impact the economy of a country is to compare the economy behavior after the creation of the protocol. That way, if the economy is not impacted by the reduction of the emission, then it is decoupling from the necessity to use that substance without reduction into the GDP, what means that new technologies and production standards are being applied. At the displayed images, you can see how the protocol impacted the CFC's emissions and what would happen if no precautions were taken. At the displayed graphs, it shows how the protocol didn't affect the GDP of Australia, United States, and United Kingdom, which is a good information, where can be seen that the economy of those countries is not dependent of ozone depleting substances, what is a good thing for the ozone layer. This new graph is also relating the economy of Australia, but with a different substance, coal. Since the majority of energy in Australia is produced with coal, it is seen that once again in 1987 no impact happened in the economic growth, and during the period of 2006 and 2010 the economy was not impacted by the reduction of coal consumption, but after 2010 the economic growth was associated with the increase in coal consumption.
How can we mend the ozone hole? Instead of trying to repair the effect of the problem itself, why not repairing the source of the problem? The only way to mend the ozone hole is to stop releasing CFCs and other ozone depletion gases into the atmosphere. The Montreal Protocol began to decrease CFCs and other gases, and the next step is to remove them completely. The most responsible chemical gases for the destruction of the ozone layer are chlorofluorocarbon, carbon tetrachloride, methyl bromide, methyl chloroform, and halons. They have been widely used as a cornice, solvent, essential duster applications, and fire extinguishers. Some alternative to these gases has been found such as HCFCs, which has many similar uses as CFCs, so they have been phased out in developed countries since 1996 and 2010 in developing countries. Most scientists now agree that within somewhere between 30 and 50 years, the hole in the ozone layer of Antarctica should disappear. This is not enough, but at least it was a good starting point. It's always better to talk and discuss problems than do nothing at all. This is the way to learn about the ozone depletion, like we are doing, is the most important step toward a safe environment in the future.